So good morning, Madam Jasila. My name is Nicholas Lindsay, and I come from the group section, lab group section 1C. And today my teammate and me will discuss about the AI in the real application. Waste management will be our main topic today. Before I start to conclude my articles review, let me simply go through what waste management is. Actually, waste management is the systematic process of collecting, sorting, treating, recycling, and disposing of waste to reduce the environmental impact and protect the public health. Later, from these 8 articles, we will clearly know how AI improves the waste management system and what is the part that need to be improved. In Article 1, it shows the YOLO V8 models, especially the YOLO V8N, can improve the waste classification efficiency. It has the best performance between the other YOLO V8 models, as it is suitable for real-time, low-resource use. But an issue need to be solved is low performance of mixed waste. Next article shows that LMNet offers efficient waste classification with low computational cost, but his accuracy is one of the problems, since he has the lower accuracy than object detection-based approaches, make it hard to use in the real life. And in the Article 3, we can clearly know that mass RCNN enable non-content CN ratio estimation for the organic waste. But the volume accuracy of this AI is also a problem. This is because the volume accuracy of this AI will be affected by the waste shape. And the Article 4 show that mass RCNN achieve accurate waste incident segmentation, but the limited category and control data restrict the real-world use of this AI. Article 5 shows the HEDWS delivers very high accuracy for disaster waste management, but its complex ensemble design increase the computational demands. Next article 6 shows an embedded deep learning system enables real-time household waste segregation. But one problem is small dataset limit the generalization of this AI. And Article 7 shows how YOLO VM based system provide an accurate real-time waste classification. We also got one issue with the Article 6, which is the limited waste category reduce the broader applicability of this AI. Last, Article 8 show that an improved YOLO V5 how an improved YOLO V5 enhance the detection of occluded bio-waste, but the model complexities challenge the real-time deployment of this AI. So after reviewing this article, it clearly proves that AI-based waste management system can significantly improve the sorting efficiency and reduce the environmental pollution. However, we observe one issue, which is the waste pollution is often overlooked by the public in Malaysia. For example, overfill bin in public space, such as the shopping mall and food court. This will lead to littering, attracting the dog and cats, causing the street pollution that threatens public health. To address this issue, we propose a smart bin system with a larger storage capacity and automated waste sorting system. Our system uses a YOLO V8 model for waste classification to reduce the manual labor and ease the burden on waste collection logistics. Next, my teammate Daniel will explain why the YOLO V8 was chosen for our smart bin system.
Thank you, Nicholas. Now, I'm going to explain why we choose the YOLO Virtual 8 models to apply to our smart bin system product. First of all, after a comprehensive and careful consideration we made based on the relevance reviews from articles, we decided to choose the YOLO Virtual 8 models be applied to the smart bin because the YOLO Virtual 8 can process the entire image once with faster speed. And it also has a low inference latency to quickly respond to the waste classification. Apart from that, it's designed with various variants which has nano, small, or medium size for flexible deployment on the bin's hardware with the limited computing power. Last but not least, the YOLO Virtual 8 model has a high accuracy rate compared to another previous version of YOLO models and the mass RCN models. Okay, next, what main functions of YOLO version 8 models applying to the smart bin? One of which are real-time object detection. The second one is the classification of waste items. Firstly, the YOLO version 8 model will process waste photos captured by an inbuilt camera in the system in real time and also in a single state. It precisely label items in photos, and after this, it can identify and classify label items into the appropriate categories of the internal chamber of the bins. And its fast inference speed and high accuracy in classification can make an excellent real-time performance to solve the waste. And now, I will pass my speech to my partner Yuan to explain what is the solution concept of the whole smart bin system.
Alright, so moving on to the next slide is about our new proposed product. Based on our research, the conventional smart bin systems are typically a bin equipped with a normal single sensor that continuously measure the bin's fuel level and transmit the data wirelessly to a central platform. This data is then used by waste management teams to monitor all the bins in real time and alert the teams when a bin is full. Therefore, for our new proposed AI smart bin system, instead of only improving the monitoring and collection functions, we introduce a new function which is a waste classification and sorting functions. First of all, for the improved monitoring functions, rather than just using a single sensor, we apply EM31 UDL ultrasonic sensor to monitor the fuel levels of the waste in all 5 internal chambers. Next, the fuel level sensor data from each chamber is then securely uploaded to the Huawei IoT platform, which centralizes monitoring and checks whether any chamber exceeds the 75% threshold. Next, once the threshold level is reached, the IOTDA rules engine is triggered and send an alert notification along with the bin locations to authorized personal via mobile applications. For the collection and route optimization functions, our smart bin system will analyze all data including the waste level data from Huawei IoT platforms and location data of all fuel bins, as well as the location data of collection vehicles through GPS tracking on the mobile applications. Next, all analyzed data along with geographical information is sent to the Huawei Elastic Cloud Server. Next, with the help of OSI routing services and algorithm VRP solvers, the system will compute the shortest distance between all required collection points to optimize the collection routes by minimizing the travel distance and balancing the workload among the collectors. Lastly, these optimized routes are then delivered directly to each waste collector mobile applications. Moving on to the next slide, it presents an overview of how the classification and sorting function works. Firstly, the process will begin when a waste item is placed on the platform of the smart bin. Secondly, the ultrasonic sensor detects its presence, while LED lighting will be activated, and the camera will capture the image. Then the image will be sent to the embedded system, where the YOLO VX model optimized with the Huawei MySport link. Then the YOLO VX model will perform the object detections and classifications. Then in the system, the waste might be classified as paper, plastic, glass, electrical components, or others. Next, the result will be sent to the microcontroller Arduino Mega, which controls a servo motor to rotate the rotary disc with the lid to the correct compartment. Finally, a servo motor will open the lid, allowing the waste to drop into the correct chambers. Then the sorting and classification cycle is completed. So that is all for me, and I'll pass the presentation back to the Nicholas. Thank you.
Thank you, Yuan. Now I will continue in the innovation and differentiation part. Compared to the traditional smart bin, we have 2 improvements will be explained in this part. The first improvement will be the intelligent AI sorting system. In our system, a high-resolution camera and the YOLO VX model are used for real-time waste classification, allowing fast and accurate single-pass detection. Compared to the sensor-based smart bin, this vision-based method provides more reliable classification by analyzing the visual feature of waste. The model is integrated with MySpotlight to ensure efficient and low latency operation on the embedded hardware. The classification result control a stepper motor to direct the waste into the correct compartment, ensuring a smooth and accurate sorting process. The second part will be the smart monitoring and collection management. Our system uses an EM310 UDL ultrasonic sensor to monitor the bin's fuel level, and a built-in 3-axis accelerometer to detect the movement or tilting of the garbage bin. A technology called LoRaWAN technology enables long-range, low-power communication for data transmission. The bin is connected to the Huawei IoT platform for real-time monitoring and send alert when it reaches 75% capacity. Cloud-based route optimization using the Huawei Cloud's ECS help us to improve the waste collection efficiency and also the task management. Next, I will pass to Huilong to explain about the market potential.
Thank you, Nicholas. And now I'm going to talk about market potential and business model for our smart bin system. There's high market potential for the smart bin system because many cities and organizations are looking for cleaner environment and more efficient waste management solution. As population continues to increase, the amount of waste generated also rise. The traditional waste management method can no longer keep up. This traditional approach relies on a fixed collection schedule and manually sorting, which lead to higher costs, lower efficiency, and lower recycling rate. The users of the smart bin system can be divided into public and private sectors. Public users include municipal councils, airports, and hospitals, where effective waste management is essential to avoid overflowing bins and ensure timely waste collection. Private users include shopping malls, universities, and factories. These users require better tools to monitor bin usage, meet environment regulation, and minimize sorting errors in order to improve the quality of recycling. In terms of the business model, the first source of the revenue comes from selling the smart bins itself. Each smart bin is equipped with sensors, a camera for YOLO-based waste detection, and an AI processing board. The target customer includes universities, malls, factories, and other organizations. By selling the smart bins as a one-time purchase, the company can enter the markets and provide customers with the basic tools needed to start using AI-powered waste management system. The second source of revenue is subscription-based software as a service or SaaS model. Users pay monthly or yearly subscription to access additional features. These features include AI analytics and monitoring, real-time waste classification, contamination alerts, fuel level prediction, usage statistics, and a cloud-based dashboard. The subscription also includes regular updates to the AI module and new system functions to ensure that users always benefit from the latest improvements. Finally, the third source of revenues comes from maintenance and professional service. The company provides yearly maintenance service such as sensor calibration, firmware updates, and retraining the YOLO model to improve accuracy. In addition, the technical support and system integration service are offered, including connecting the smart bin system to the user's existing management system. This service helps ensure the system reliability and build long-term partnership with our customer. That's all from me, and now I'm going to pass my mic to Yan Yu.
Thank you, Huilong. Now we come to the last part, which is the future roadmap. For the future roadmap, we propose to integrate both the YOLO version 8 models and the MUST RCNN model in the system to develop a two-state computer vision solution. The YOLO version 8 models can optimize the speed in call classification, and the MUST RCNN models can perform improvement in instant segmentation to generate the highest possible fidelity pixel-level MUST data, which outlines the precise shape of the objects. Besides, the smart RCNN models can also improve the softer material purities and properties for a better performance in classification. Moreover, we also propose the MUST bin can be installed with a vision system using a depth camera to combine three-dimensional data captured by the camera in the system with the MUST RCNN segmentation MUST to precisely calculate the volume of the waste. Lastly, we can integrate advanced quiz and excitation modules to enhance the representation power of convolutional neural network for better capturing small items that are difficult to detect from the waste. So our presentation is going to be here. Thank you.